everyone. Welcome to Doctoral Science. Now, there's a very simple question here I want us to look at together. The question is this. A glass flask has a capacity of 500 cm3 at 100 degrees Celsius. If the coefficient of linear expansion of glass is 3.2 times 10 raised to the power minus 6 degrees Celsius, find the capacity of the glass flask at 30 degrees Celsius. And here the options were given. Okay guys, now this is one of those simple and interesting topics, and learners enjoy this in physics. But you know one thing, this question is simple, but you must pay very clear attention, else you will miss something very important. Now let's go through this so that you can understand why I say so. We're told that this glass flask, of course that's a solid, right? The volume at the beginning, let's say that is V subscript 0, was 500 cm3. And the temperature at this point, when the volume was 500 cm3, let's call it theta subscript 0, was 100 degrees Celsius. And we are told that linear expansivity for the glass solid, that means the rate at which this glass flask increases in length for every degree change in temperature, is 3.2 times 10 raised to the power minus 6 per degree Celsius. Okay, you know what? Then we're asked to find the volume of this glass when the temperature, let's say theta 1, becomes 30 degrees Celsius. That means we need the volume when temperature is 30 degrees Celsius, and we take that volume to be V1. Now notice the temperature reduced from 100 to 30. Now let's find the change in temperature. Change in temperature is going to be theta 1 minus theta 0. Of course, that is 30 minus 70. So change in theta becomes 30 minus 100, that would be minus 70 degrees Celsius. Okay? But remember, we are dealing with volume. There's that relationship between cubic expansivity or volume expansivity and linear expansivity. So we remember volume expansivity is 3 times linear expansivity. So we can say this is 3, the linear expansivity is 3.2 times 10 raised to the power minus 6, and that's about 9.6 times 10 raised to the power minus 6 per degree Celsius. Okay? Now we are getting somewhere. Now this is where I notice some learners make mistakes. Of course, they remember that change in volume is V1 minus V0. Also, change in volume is initial volume multiplied by volume expansivity multiplied by change in temperature. So change in volume is V1 minus V0. Change in volume is also product of initial volume multiplied by volume expansivity multiplied by change in temperature. Now this is one thing I notice most learners do. So they go about saying V1 minus V0 is equal to V0 gamma change in temperature. This is good. No problem. Now what do you notice? If you make V1 subject, because that's what we're looking for, you have to move minus V0 to this side. So we'll have that V0 minus going, it becomes plus. Okay, V1 is V0 plus V naught gamma change in temperature. So you see there's V naught here, there's V naught here. You can just make it simpler by factoring out V naught. You're going to have 1 plus gamma change in temperature. Now with this, all you need to do is substitute the value of V naught which was given, substitute gamma which you know, substitute change in temperature which we also know. Now let's go about doing that. So this is V1 is 500 for V naught into 1 plus gamma is 9.6 times 10 raised to the power minus 6 multiplied by change in temperature is minus 70. Now, do you know what? Most learners don't take that minus 70. They drop the minus and go with 70. Now, see what happens. If you go with that plus 70, okay? So you're going to have 500 into 1 plus 0.000672. And when you do that, you have 500 into 1.000672. And this answer will be 500 plus 336 cm3. Now, there's a little problem with this answer. When you go to the option, that is option A. So for a learner that does this, you go to the option, you see the answer, you think you're right. But when you go back to the question, look at this. It's going to increase in size if temperature increases. But the size must reduce if temperature reduced. How do we notice that? When the temperature was 100, the volume was 500 cm3. Now that temperature has become 30, temperature reduced. So you expect the glass to contract. If the glass is supposed to contract, we are not supposed to get a value up to 500. It's supposed to go down. But you see, our final answer here is more than the initial volume. So that should tell you something is wrong. Why? The minus we dropped. So how do you correct it? Simply go back and put the minus where it's supposed to be. Where is that? Here. That is where the error is. So this is 1 plus gamma is 9.6 times 10 raised to the power minus 6. Then times change in temperature was minus 70. That's where the error is. Many of them did this. That's why I decided to solve this question so that we can see how that came about. So here is 0.000672. Okay. Having done that, you see your V1 will be 500 multiplied by 1 minus this will give you 0.999 328. Now when you multiply what is in the bracket by 500, have about 499.664 cm3. And by reasoning, this volume is less than the initial volume of 500 degrees Celsius, agreeing to the fact that temperature reduced and there should be a corresponding reduction in volume. So if you don't understand the theory behind what you are doing, that's option A seems to be your answer, and that would be very wrong. If you have brought in the minus, the correct answer would be option D, 499.664 cm3. Thank you.